take just a moment to look at the software interface for Oligo 7. Oligo 7 is one of these tools that we've mentioned for primer design. Now we're looking at a demo that's made available, so this is not the full featured function that would let us load arbitrary sequences. We're just working through the demo provided with the code itself. So we see that a sequence of 1,868 nucleotides has been imported into the software. This is a reverse transcription of the mature messenger RNA for human, specifically the eukaryotic translation initiation factor 4E. Now, as we look at this whole sequence, we can see that we know the reading frame where our sequence, the translated sequence comes from, is reading frame number 1, and that our current location is sitting at a current oligo length. The primer length that we're looking at is 21 nucleotides. And you can move that around arbitrarily within the sequence. In each place, you should see that the position is changing and also that the melting temperature is changing. So 57.8 here. If we were to scoot to a different part of the sequence that's a little lower, we would see it drops to 52.7. So where we are within the sequence is going to change the melting temperature of the primer. So this bar plot that we're seeing up at the top shows us the melting temperature that would be associated. I think if this were the middle or the start of the primer. Now, we would like to know a little bit more about how our gene relates to this piece of DNA. And in this case, we can make use of the Analyze menu. You see that there are many options available to us here. We can search for duplexes within the sequence, hairpin formations, the composition changes, and so on. Lots of different options. But in this case, what we care about is open reading frames. We're going to analyze to say, where is the translated sequence coming from, essentially. So as we open that, we see that our initial assessment, the initial information we were given, is correct. Reading frame +1 is the one that has all of the sequence that we care about for translation, stretching from here at position 1 up to here. Now, we'd like to have a little bit more information about this. I'm simply going to click on that reading frame to select it. And now we can see that it stretches from position 1 to position 651. It codes for 217 amino acids. Now, obviously, that's going to be this divided by 3, that the number of nucleotides divided by 3 gives us the length of the protein. If we were to translate that, the molecular weight would come to just over 25 kilodaltons, with a mean pKa value of 7.4. So we have that information. This gives us a piece of feature information. Where is the open reading frame within this? So let's keep the numbers 1 through 651 in mind for just a moment. We return to this and we see that a feature has been defined for this sequence stretching from 1 to 651. So that information is already here. Now we would like to find a set of primers that would produce a PCR product of at least 150 base pairs drawn from within that coding sequence. So we're going to start a search for primers within this sequence that meet that criterion. We have a whole bunch of different options here. I'm going to focus on, I'm going to take a quick moment to look at parameters because it's important. As we mentioned, there are lots of different features of these primers that we're going to score in some way. You can see that those scores are going to be derived from how we run our PCR experiment. So how much free magnesium and sodium you've got in the mix is going to have something to do with how this PCR plays out. If you look at the scoring, you can see that there's a wide variety of facets of these primer sequences that must be taken into account that all get combined into some score of goodness for each primer. So I'm going to back out of parameters and return us to the search mode. We're now going to click on ranges. Remember, we said we didn't want to look throughout the whole piece of DNA, just within the coding sequence itself. So we're going to specify that we want primer products that start at 150 nucleotides in length. So that's our first requirement. And we want to specify that these must fall within our coding sequence from region 1 to 651. You can see that this is already checked. So I've already specified that this is the short range I want to include. I'm not going to make any changes to that now. But I will go ahead and click OK. Let me see, now have we specified? Oh, yes, we're going to find products only within the checked region. So anything outside the coding sequence just doesn't exist for the purposes of primer selection. All right, so I click OK on that. And finally, I start my search. And back from that comes a set of primers. You can see that they're specifying forward primers and reverse primers, where they start in each case, what is the product length as well, so you know kind of how big a chunk of the coding sequence is going to come out, what is the optimal temperature for annealing, and what is its percent GC. So these are the kinds of things you can do within software of this sort to help you tune the process by which you select primers. And although this is a pretty user interface, the kinds of options you would get here would not be substantially different from what you'd find probably in like an open source toolkit as well. But this one is certainly well tuned to be easy to use for us.